Hi everyone, welcome to our Designing Data Products project presentation. Today we will walk through our data-driven product, Contentify, which leverages Medium articles to generate actionable insights into reader engagement trends and content effectiveness. This presentation will cover our project objectives, data collection, cleaning and pre-processing steps, model selection and development, refinement stages, the business impact of our product, and an evaluation of its limitations. Our primary objective is to create a predictive model to determine the factors that make a Medium article engaging and widely read. This involves a prediction task, where our goal is to predict whether an article will have high or low engagement based on its content and metadata features. The prediction is actionable because it provides content creators with insights into factors driving audience engagement, making it a valuable tool for optimizing content strategy. To build our model, we gathered data from Medium's website using web scraping techniques. Our sources include metadata about articles like publish date, author, tags, reading time, and textual data.
All right, so quick tutorial how I did the web scraping. I basically went on medium.com and searched for a random tag and opened an article and inspected the network tab on my browser. So I go to the network tab. Let's reload this page to see what kind of requests we're getting. And then I saw that there's these GraphQL requests that seem to be returning a bunch of interesting data. So I basically sifted through them until I found the one. You can see there's like a bunch of them. I looked for the one that was actually returning a list of content. And then I looked for how it was authenticating that. And I could see that the main way it does it is once you're logged in, and I'm logged in on this browser, it attaches this cookie. So I basically took the entire curl request here, copied it, then went to Postman and basically saw if I could run this exact query, adding all the headers to make this API request look like it's coming from a browser client. You can run this one and then you see this is basically what's returned. This thing, put it into VS Code just to take a look and analyze it a little bit, see, okay, what are the different items that are, like what are the different keys that are in one of the posts, and then kind of mapped out what I wanted to save. Then I went into Supabase, which is like an online Postgres database. I created a table called articles that I basically like added the columns that I think I needed. So title, subtitle, creator, all of this stuff is like out of here basically. Medium URL, visibility, clap count, all that stuff, reading time. Created a bunch of columns here. The next thing I then did is I went into Python and wrote a little script called medium get metadata. Looked for a bunch of tags that I found were relevant on Medium and made a list of basically to loop through all of them. I'm going to comment all of the ones out for now that I'm not willing to scrape again. And then wrote some code to basically out of this giant JSON file, like extract the right keys and items and subgroups, so that I can create basically a new row to insert into my database with all those columns. And yeah, that's basically it. And then you can just kind of run it and it will go and it will scrape the data from that page. This is how I scrape the actual content of an individual article. So not just the metadata that I get with the GraphQL API, but basically converting this stuff here into nice markdown format, like basically taking this giant HTML thing and converting it into a nice readable markdown that looks like this. So you can load the full value, you can see the details, and this is basically like a markdown representation of that particular article. So, and the cool thing is that you can pass through a authentication cookie. So I'm passing Firecrawl, the cookie that I used, and then they pass it to the website just so Medium thinks it's like I'm using it from the browser. And once I have the markdown, I just add it into Supabase and let it run. And I have some logging. I always do like 1,000 at a time, and I have some wait times in here because if you scrape too many things too quickly, then you will get blocked and it won't work. But yeah, you can see, for instance, this one just got updated. There's a nice little green success message. So if we just take this particular URL and we look in Supabase to see medium URL, there it was, medium URL is equal to this, we should see that, okay, the article markdown is now filled. And if we open up, we can see that there is content here.
Data cleaning was essential for handling missing values, standardizing data formats, and removing noise from text content. For example, we handled cases where metadata was incomplete or text contained formatting errors. This rigorous cleaning process was crucial as it ensures that our model learns from high-quality data.
With respect to feature engineering, we focus on three main aspects to enrich our dataset. First, sentiment analysis. It allowed us to capture the overall tone of the article using tools like TextBlog and Vader. This allowed us to see if there was a positive or negative tone impacting engagement. Second, we used topic modeling with LDA to identify the main themes of each article. Adding dominant topics as features gave us insights into which themes might resonate the most with readers. Finally, we calculated a readability score for each article, using the FK skill to assess if readability affects engagement. In our modeling phase, we created a training and test split of our clean dataset to ensure that we could evaluate the models effectively. We developed a total of 3 models, 2 of the models for numerical features and 1 model for text features. Our first numerical model was a baseline linear regression. We used this to establish a simple relationship between reading time, subscriber count, and the target metric, which is the log transformed clap count. While this model gave us a basic understanding, it struggled to capture the full complexity of the actual data. To address this, we developed a random forest regressor as our second model. This model was better equipped to handle nonlinear relationships, and as a result, it showed an improvement in predictive power, especially as it reflected in the higher R-squared score. This indicated a better fit, though we recognize that even the random forest model had its limitations in fully capturing the dynamics of engagement of a Medium article. Next, for the text analysis model, we explored features such as title, subtitle, topic tags, and alt tags, using a linear regression model with a bag of words representation. We log transformed the clap count to manage skewness and improve interpretability. This model provided insights into the role of content features on engagement, but we found that the bag of words approach only captured so much, as text features often require a lot more nuanced analysis. Despite these limitations, we were still able to identify a few key insights. For example, the numerical analysis correlation heat map right here actually shows relationships between numerical features, highlighting a strong link between the clap count and post responses. This suggests that the articles with more claps tend to receive more responses, indicating reader engagement. Secondly, we also did a numerical analysis feature distribution. Our feature distribution plot shows that clap count and post responses are heavily skewed towards the lower values. This data skew may impact the model's ability to predict high engagement articles accurately. Next up, first, the distribution of log transform clap count. Applying a log transformation to clap count helps normalize the data, making it easier for the model to detect patterns, especially within the lower and mid-range engagement values. Next, with respect to the distribution of reading time, the log transformation of reading time also smooths out the skew, giving us a more balanced view of article lengths. This helps the model better understand variations in reading time without extreme values overshadowing the analysis. Using the linear models on title and subtitle features, we're able to see that there's a straightforward baseline for understanding their predictive power. Although it's effective for general trends, these models are most likely missing the actual complex relationships within the title and subtitle text. Finally, with respect to tags, applying the linear model here, while it was informative, it's most likely overlooking tag combinations that contribute to an article's reach. However, applying random forest models here allowed us to actually help identify which specific tags or tag interactions correlate strongly with high engagement. Next, let's discuss the limitations of our modeling. There's a noticeable bias towards certain popular tags, which could skew our predictions. We've decided that our future iterations of the model could incorporate articles from a wider range of sources, such as LinkedIn, and apply de-biasing techniques to balance out these influences. Second, we found that certain filler words like use and self appear frequently among the most top popular important words. However, these are less meaningful in understanding engagement. To address this, future models could analyze 2-word combinations like use case or self-made to provide more relevant context for engagement prediction. Lastly, with respect to productionalizing our actual model, we envision deploying it as a practical and predictive tool for content marketers, marketing managers, and content creators so that they can use it to identify what content might work best on Medium. This tool would help authors predict engagement and refine their content before publishing, as well as help startups and small businesses actually hit keywords when trying to get marketing reach on Medium. In terms of scalability, our model offers a real-time feedback on key factors like article length, topic tags, and sentiment, making it practical for a high-volume use case. You can also find all the resources that we use on this slide. And thank you for listening to our presentation.